Can you hear me? Okay, we're going to go ahead and get started. I think Ivy was typing a response, but I'm going to wait for a second. We're going to go over 1.10, 1.11, and 1.12 today. Okay, so section 1.10 is on scatterplots, and if you look in your textbook, in the ebook on page 80, there's a little box like this, and it talks about what a scatterplot is. It's a graph that shows the relationship between two quantitative variables, two numerical variables. The horizontal axis represents one variable that we call the independent variable, and the y-axis represents the other variable. By independent, I mean we think that this variable somehow influences the y variable. And all the points on the scatter plot are actually ordered pairs. So for instance, if I pick, trying to see one that's kind of easy to look at, like this point right here, the coordinates of that would be around 140, 40. Okay, neither axis in this example starts at 0, and they put a little jagged line here to show you that they broke the axis, that they didn't take it all the way down to 0. So if we look at this scatter plot here, we see as the horsepower increases for a car, as we might expect, the miles per gallon go down. So the stronger or the more powerful the engine is, the poorer the gas mileage. So again, here's the independent and dependent variables. So the variables are paired. One is thought to depend on the other, and the one that depends on the other is called the independent. The other is called the dependent. The other is called the independent variable. And again, if you look at that scatter plot we just saw, we said horsepower was the independent and miles per gallon was the dependent variable. So after choosing which variable is independent and which is dependent, we have to do a scale for each axis. You want to think about the smallest and the largest values that have to be graphed, and then choose a consistent increment or step to cover the distance between them. Once the axes and scales are determined, plot each pair of values as an ordered pair on the graph. The value of the independent variable is the first number in the ordered pair, and the value of the dependent is the second number. And by the way, when we create a scatter plot, we don't connect the points. We just leave them as points on the scale, on the graph rather. So again, what's going to be the independent and what's going to be the dependent variable? And in this example, we're looking at the hours of studying and the college GPA. So what do you think might be the independent? Which variable do you think might influence the other variable? Would the hours of studying influence GPA? Or would GPA influence hours of studying? Anybody want to try that? What would be the independent variable? Hours, absolutely. Because the more you study, you would think the better you would do. And so if we take a look at, if I go back just for a second, remember what we said, look at the values here. They go from 2 to 14. So we might say, okay, we're going to do our scaling from 0 to 15. Maybe with units of 1 or 2 on the increments. The GPA, the smallest one we have here is 1.8 up to 3.8, so maybe we go from 1 to 4, or 1.5 to 4. There's not necessarily a right or a wrong way to do it. They actually started at 0 in both cases here, and then they plotted the points, and notice they're not connected. So mathematicians often look at scatterplots to try to find some kind of a pattern that the data points seem to follow, even if it's not perfect. So if we go back to the example we just looked at, if we notice here, we could almost drop a straight line across the values. It's not going to fit perfectly, but it looks like what we would call a linear relationship. It follows a straight line. Again, not perfectly. And the process of choosing the appropriate graph is what we call mathematical modeling. So for each of these, let's see if we can sketch a curve through the points. This is on page 84 in your book. And let's see what we think here. So look at this one. So as the years of repayment, as we pay more of our loan back, what happens to the amount of our student loan or the debt? It's going to go down. And this looks like a pretty straight line, actually. Again, not perfect, but I could probably draw a straight line across there. And then how about this one? As the square footage of the house increases, the selling price increases. And again, it almost looks like I could drop a straight line on there. Again, every point is not going to fall on the line, but we're trying to model. And then look at this one. This one's definitely not a straight line. As the selling price goes up, the revenue goes up. But then at a certain point, what happens? People stop buying because it's too expensive. So if we try to fit a curve to that one, it actually would be a curve like that. All right, let's try. This is from your book also on page 85. They've got 6 graphs in this example, and they want you to look at each situation here and pick first of all, tell us the independent and a dependent variable, and then which graph matches the situation. So let's look at this one. You save the same amount of money each month in an account until you reach your goal, and then you leave it at that balance. One thing I should mention, in a scatter plot, generally if there's a time factor there, it becomes the x variable, and we do see a time parameter in this example, months, right? Because every month we put in the same amount. And so months, so the 2 for this one, let me show you what this one is. The independent here is going to be months, and the dependent is going to be the balance in your account. How much money do you have? Okay, does anybody want to pick the graph that fits this scenario the best out of the 6 graphs here? Anybody want to take a chance? What do you think? I see an F. Correct, Abby's right. Because what did we do? We put the same amount in each month, and then once we hit our goal, we left it there. All right, let's try another one. The average monthly temperature in a given location. So again, we have a time parameter, and like I said, generally that's going to be the independent variable. So months is independent. What's my dependent variable? What are we looking at here? The relationship between the months of the year and the temperature, right? So the dependent is going to be temperature. So which graph do you think fits that one best? And think about over the course of a year, anywhere in the world pretty much, there's some variation in temperature, right? So anybody want to try to pick a graph for this one? Yeah, E. Yeah, there's some fluctuation here. So if we looked at this as this was summer and this was winter in Florida, there is still some fluctuation. Okay, let's try another one. A population of bacteria doubles each hour. So again, there's that time parameter I mentioned, always generally is going to be the independent variable. And then it's doubling, so we're looking at independent is the hour and the dependent is the population number. And let's see, Abby said C. Okay, yeah, that's right. Because what happens here is it keeps growing and growing and growing and growing. So if a graph were to continue, it just keep going and going and going. Okay, let's try another one. The height of a ball each second, notice the time parameter again, after it's shot from the catapult. So the independent again here is going to be seconds, yeah, and it's going to be A, yeah. And the dependent is the height, and you notice when you shoot something up in the air, eventually gravity pulls it back down to Earth. Good. We have 2 more. This one's a tricky one. The number of days needed to build a bridge compared to the number of workers. Now this is one of the times when, although there's a time parameter here, it's actually the days is going to be the dependent, the number of workers is going to be the independent. So which graph do you think it is on this one? This one's a trickier one. Very good, Abby got it. Think about this. As the number of workers increases, the time to build the bridge is going to decrease. So it's a decreasing relationship. Very good. And one more. The number of students on a college campus that contract a contagious flu virus. So although they didn't mention, yeah, it has to be B. It's the only one we didn't use. The independent here is going to be, we're going to say days, let's say. And then the dependent is going to be the number of students infected. And it is this one because it's going to go up and eventually plateau, because once all the students are infected, then we can't infect anybody else. So there's notice the difference between this one and this one. This one's flattening out. This one's going to continue to increase. Okay, so that's kind of a fun little chapter. This section here is on converting units. And this is where we want to go from one type of measurement to another. And you want to think about the relationship. Your book shows the use of pictures if that helps you. You need to think about whether you're going to multiply or divide, calculate, and then check. And so, for instance, if we want to convert 120 pounds to kilos, and there is a handout in the Unit 1 folder with conversions for you, and there's a conversion in there that 1 kilo is 2.2 pounds. So for every kilo, there are 2.2 pounds. So we're going to divide, because we expect to get a smaller number of kilos than we have pounds. So we're going to divide and get an answer of 54.5. And there's part of what's on that handout for you, a lot of conversions. So let's try a couple examples. If you're 5'6" tall, are you 5.6 feet tall? How tall are you in inches? All right, let's do the first part first. No, 5'6" is not 5.6. 6 inches is actually a half a foot. So if you're 5'6", which I am, I would be 5.5 feet tall, or 66 inches. So how did I get from feet to inches? I know there's 12 inches in a foot. So I multiply 5.5 times 12, or I simply multiply 5 times 12 and then add the 6. So you're 66 inches tall. All right, you go to a movie that's 189 minutes long. Your friend is seeing a movie that starts at the same time, but it's 2 hours and 10 minutes long. Who will be finished first, and by how many minutes? All right, so I would convert everything to minutes. So if I look at the first movie, it's already in minutes, right? 189 minutes. Your friend's seeing a movie that's 2 hours and 10 minutes, so that would be the equivalent of 130. Yeah, Let me put that up here. So 2 hours, 10 minutes equals 2 times 60 plus the 10, which is, plus 10, which is 130 minutes. Okay, so who's going to finish first? Your friend is, right? And by how many minutes? Now all I need to do is compare the 189, let me get my pointer, 189 to 130, and so we come up with 59. Yep, absolutely. Very good. Excellent. All right, let's try a couple here where we have to kind of chain a little bit. So we want to go from millimeters to liters. Millimeters to liters. All right, so you've got a conversion for that. I didn't put the conversion table up. Hold on just a second. Let me see if I brought it up into my folder of materials. I don't think I did. But you do have a conversion in there. Oh, no, I don't have it. Okay, you do have a conversion in there that tells you what? 1,000 milliliters in a liter. So what am I going to do? Am I going to multiply or divide? I'm going to divide. And the reason I'm dividing is I'm going from smaller units to bigger units, so I expect to come up with an answer that's smaller. And the conversion here I used was 1,000 ml equals 1 liter. And I divided. All right, let's try another one. 5 kilos to grams to milligrams. Now we're going the other way. We're going from a large unit to a smaller and to a smaller. So I'm going to end up with a much larger answer. And what are your conversions that you can use here? Anybody want to look those up and tell me? Or what, does anybody know those conversions? How many grams in a kilogram? Okay, 1 kilogram is 1,000, whoops, too many zeros, 1,000 grams, and 1 gram is 1,000 milligrams. So what did I do to convert? I simply multiplied. I took 5 times 1,000 and I got 5,000 grams, and then I multiplied again by 1,000 to get 5 million milligrams. So again, notice the large answer here because I'm going to a much smaller unit than I started with. This way I went the opposite way. I went from a very small unit to a large unit, so my final answer was a smaller number. Convert 500 milligrams per hour to milligrams per day, and then to grams per day. All right, so first you want to go to, how are we going to go from 500 milligrams per hour to milligrams per day? Multiply by, oh, it's not showing up too well. Here you're going to multiply by 24, because we have 24 hours in a day. And then you want to go from milligrams to grams, so what are you going to do? And you can just about see it down here, divide by 1,000. So it's 12 grams per day is equivalent to 500 milligrams per hour. You could almost think through this. Let's just think for a second here. 500 milligrams is a half of a gram. So every hour I get a half a gram. Every 2 hours I get 1 gram. And how many 2-hour segments are in a day? 12. So 12 grams per day. So there's another way to kind of rationally think through that one. Convert 2.5 miles to yards by changing the miles to feet and then the feet to yards. And let me show you this. This is what we call dimensional analysis, where we do it all in one step. So I start with the miles and I say, okay, I know there's 5,280 feet per 1 mile. And then I know there's, in 1 yard, there are 3 feet. And if you notice, I go across here. This is what we call canceling the units to make sure you set it up right. Numerator, denominator, miles cancels, feet, feet, miles cancel. And what am I left with? I'm left with yards, which is what I wanted. And the answer is 2.5 times 5,280 and then divide by 3. So 4,400 yards are included in 2.5 miles. Let's see if I have another one. Okay, that was it for conversions. They're not too difficult. It's the multiplier divide that you're really going to have to think about. Do I multiply or do I divide? All right, and then our last section is percent change. And there's an example on page 100, and I want you to, if you can understand this and get this concept, it's really useful. It's called multipliers. Let's decrease $100 by 5% using 2 steps and then using 1 step. So to use the 2-step approach, we begin by finding 5% of 100, which I did here is $5, and then what do? I subtract it, so I end up with $95. Now let me show you how to do it in 1 step. Maybe if I can get my slides to move ahead. There we go. So we began with a whole, which is 100%, and we took away 5%, which means we subtract 5%. So how much is left? 95%. So if I take the original amount and multiply by this, we call this a multiplier, I get the answer in 1 step instead of 2 steps. This is a really nice thing to learn because it's also helpful when we do exponential functions. The multiplier will allow you to do a problem like this in 1 step. All right, let's try a couple examples. So find the multiplier for each percent change. So I want to increase by 22%. So remember what I said. I said I started at 100%. Whoops. Sorry. Let's try again. 100%. There we go, 100%. And then I added 22%. So where am I now? I'm at 122%. Or move the decimal, divide by 100, move the decimal 2 places to the left. 1.22. So my multiplier is 1.22. How about if I wanted to decrease by 22%? All right, so I started at 100%. I took away 22%. So what's left is 78%, and my multiplier is 0.78. All right. And again, here's a block on 101 that shows you the 2 different ways to work a problem with the 2 steps or with the 1 step. And I'm going to say, if you can learn to use the multipliers, it will save you a little bit of time, but you can certainly do it by the 2 step. So let's try some examples. Interpret the multiplier for each percent change. So what kind of percent change do we see if we're using a multiplier of 1.37? So this is kind of going the other way. Now be careful, we started at 100, so we actually ignore the 1. So how much is the increase? It's actually, Abby, just the 37%. See the difference? You started at 100% and then you added how much? So for instance, if I had 1.93, what would my percent increase be? So again, ignore the 1. As long as it's 1 or higher, you know it's an increase, number 1. So this would be 93%. Yep. Now let's do a decrease. If there's no 1 in the front here, you know it's a decrease. And how do you find the decrease? Subtract this from 1. So you actually have what percent? Absolutely, 49%. Yes. Okay, does everybody see that? So when the number's 1 or greater, you're going to look at the decimal part to get the percent. If it's no 1 in the front, if it's less than 1, you're going to subtract it from 1 and change it to the percent. Okay, this is kind of a fun problem. This is actually out of the homework in the textbook on page 105. So I've got 4 statements here, and I want to know which ones are true. The price of an item in an online auction went from $200 to $400. Determine which of the following statements are true. There was a 100% increase in the price. this one's true. Absolutely, this is true. And let me just jump over here for a second to another whiteboard. So remember how we find percent change. Whoops. Let me erase that for a second. Let me go back. So percent change, if you remember, and this is in your book. I don't know if I put it in. Hold on a second. I think it's in one of the blocks in the book. Yeah, here it is, back on page 104. Let me jump back for a second and try, instead of trying to write it. Let me go back here. It was in this block right here. Oh, went too fast. Here it is here. Here's your percent change formula. Okay, so page 104. Remember percent change. Final minus initial divided by initial, and then we multiply by 100. All right, so let's go back to this one we were just working on with the statements. Here we go. So this is true. What was the change in price here? 400 minus 200 is 200 divided by the initial 200. You get 1 or 100%. That one's true. How about this one? The new price is double the initial price. True or false? I made a mess there. True or false? The new price is double the old. Yeah, that's true also. How about C? There's a 200% increase in the price. True or false? Remember what you said in A. So can C be true? Yeah, this one's false. If A is true, then C has to be false. How about the last one? The new price is 200% of the original price. All right, so let's do this one. So the new price, 400. Now I'm not doing a change here. Whoops. Let me type it. It's a lot easier. So I'm looking at 400. I'm not doing a change here. 400 divided by 200 is 2. And if I multiply the 2 by 100, what do I get? I get 200%, don't I? This one's actually true. So the last one is talking about not the change in price, but it's talking about the new price. And the new price is double, because that's the same thing as what you said in B. The new price is double the initial price. So they're all true except for C. All right, a couple other examples. At a meal or dinner, the meal bill is $42. Find the amount of the dinner with a 20% tip added to the total. All right, so let's think about this. If we wanted to do this in one step, what's the multiplier? So here's my 100%. It's my $42, and I want to add 20%. So what's my multiplier going to be? Anybody want to try? What's the multiplier going to be? All right, so we started at 100. We added 20, so we get 120%. So the multiplier is 1.2. So if I take 42, multiply by 1.2, I get $50.40. Yep, good. Does anybody else know a quick way to do tips? I always like to talk about this because I know that servers really deserve to get good tips. So if you take 10% of $42, right, exactly, Abby, but the easy way to do it is, what's 10% of $42? It's $4.20, right? So 20% must be $8.40. And that's exactly what we added here. So just a quick little hint for how to figure out tips. Okay, fill in the missing pieces here. All right, so this is in your homework. This is why I wanted to show it to you. So it gives you the original price. It tells you what's the discount. You don't want to use a multiplier here because they want the discount and then they want the sale price. So to find the discount, what do? I'm going to take 0.26 and multiply it by the price I started with. And I'm going to keep all the decimals for a minute. I got $5 at 5.304. And then the sale price is going to be the mark price minus the discount. And so I get $15.10. So I've got $5.30 here and $15.10 here. You have a homework problem like that. That's why I showed it to you. Showed you this example. And then one more example. A TV is discounted from $300 to $167. Find the percent of the discount. All right, so what's the discount? 300 minus 167, so it's $133. And then I want to compare it to what? Where I started from. So we're going to compare it to the $300 that we started at. get the decimal and multiply by 100. And I think in the homework they ask you to put one decimal, so 44.3% is the amount of the discount on this problem. So this is kind of like the last one, but a little bit different information. They didn't give you the percent of the discount, they gave you the amounts and said find the discount. Okay, so that was 10, 11, and 12 in cycle 1. Anybody have questions on any of the problems or having any difficulties with any of the problems or sections? Okay, Abby's doing good. Alicia, how you doing? Okay. Okay, great. All right, everybody, have a great week. Oh, no chat next Monday. Labor Day. I will post a recording of the material. Oops, I'm trying to get to type correctly here. Recording. Okay, so we'll chat again in 2 weeks. Next live chat on September 11th. Huh? Okay, have a great week.